What I'm saying is if we go back to, like, the plan, this is literally... Oh, and that was meant to take 2 days, too. We just didn't.
Exactly.
So, this is meant to take 2 days. We'll see what happens, but if that's the case, then the homework breaks up. So, notice... Hey, look, I was already prepared for this ahead of time. I don't have set, like, firmly what we're doing tomorrow. No, we cannot not do anything because we have to at least exist. So, at a minimum, we could potentially maybe play a game tomorrow that involves conditional probability. There's actually a game that I am thinking of.
Play euchre.
No. So, we also couldn't because there's only 3 of us.
Can we play
Jake,
spoons?
get better.
Can we play spoons?
No. So, any game that you're going to throw out, I'm probably just going to have to say no to, which then you're making me feel like the bad guy. But I want to be pushing you guys outside your comfort zone.
Is it a new game?
Well, it's new for me.
What's the game?
Anyone ever played Welcome to?
No.
Well, you look boring.
I know. I always look boring.
All right, well, let's just do math. If you're going to be pouty pants about the game that we might play, then I guess we can just do math.
Okay.
You know?
Oh, thank you very much.
It looks pretty cool. I don't know.
Akshaya just wants to be pouty just to be pouty.
I want to play spoons.
I don't care what you want to do.
I know.
You complaining about things makes it less likely that I'll do what you want to do.
Well, you never do that.
I want to take a nap, but you can't just have
Yeah, we've never, ever stopped class and just played a game.
Yeah,
We've
but
never,
because
ever
it
done
was
that.
Jake or Connor said that. I never did that.
Because you don't play games.
I play card games.
Liar.
You see me play spoons all the time.
Welcome to is a card game.
Still, I like actual playing.
Ha! You're not open to playing games. You're only open to the things you want to do.
Exactly.
You don't have a very much growth mindset right now.
growth mindset. Is this like 4th grade when the...
It's hard to tell if you're blinking or not because of the reflection of the screen.
Okay.
Grab graph paper, please. Quicker we get through this, the quicker... I don't even remember how to play spoons, quite honestly. I was going to say the quicker we could potentially play spoons. It's been a long time since I've played spoons.
So it sounds interesting. I think it's like musical chairs but card games.
I'm going to double check, make sure Jake didn't respond, because I told him if he wanted to zoom into class, we could do that.
Does Jake have COVID?
Yeah.
He at least is in quarantine. Beyond that, I do not know.
'Cause we got-
Even if I did
Can we
know,
get a
there are certain laws that protect people's privacy, especially about health things, and I would not be able to tell you anyways.
Hey, actually, did you get a letter that said you were in close contact with somebody with COVID?
Yeah.
Yeah. I think it's Jake.
Yeah.
Well, good thing we all sit kind of far apart and wear our masks in here.
Uh-huh.
All right, so I got a question for you. Of course. So in this children's game called Build a Farm, okay, I guess I'll continue reading it. Half of the spinner's red and half of the spinner's blue. The spinner lands on red, you reach in the red box. Spinner lands on blue, you reach in the blue box. What is the end probability of each individual animal happening?
Oh.
Oh.
Wait, that's not that hard.
What sort of model would be best to represent this? And then calculate all the probabilities. When we total all the probabilities up with each other, what should we get? 100%. So this is conditional because there are multiple steps to it, right? Reaching into the red or blue box is conditional on the first result of the spinner, which fortunately here is half and half, but won't always be.
Yeah. So it's really easy.
Whoa, bad word.
Oh, well, it's true, though. Okay.
It's true.
10 pigs, 10 cow. So, you got a 50-50 shot. So basically, from the red box,
So what would be a good model to use to represent something like this with kind of like 2 stages of things happening?
it's a tree diagram.
It's a tree diagram, Connor says. Actually, are you alright? You seem kind of off this week. Right? You're off a little bit. You're fine. You sure? That's true. You don't seem like your normal self.
I don't know.
Maybe you miss Jake.
No.
Maybe our
definitely
class of
not.
2 people is just not jiving for
That's
you.
definitely not it.
Well, that was rude.
Okay, so that's a half. So 20%. 5% cow, and so the end results are 45% pig, 30% cow, 25% chicken. Yeah.
Like their total probabilities
Yeah.
was what did you say?
45% pig, 30% cow, 25%.
I don't think so.
I disagree.
All right, show me why you disagree.
Because 50% times 50% is 25%. 50% times 50% is 25%. 50% times 50% is 25%.
So they're all 50%?
Yeah.
They are?
Wait, how many times are you running it? Is it just once?
Probability doesn't matter how many times. That would be for expected outcome.
Oh, okay.
I might as well do this in like pink or something to code that.
Has the same probability as
Your probabilities are not correct. So I need you to open your brain to the fact that there's a mistake somewhere. We need to track it down.
So if you make the red box and the blue box 2 separate probabilities, like you got the blue probability table, which is 50%. Oh, it has 10 chickens in it. Well, that's what the problem is. I didn't read the question.
Man, who would have thought that reading the question would be beneficial?
Yeah, you know, I don't know. Some weirdo probably.
Whoa. Thanks for pegging me as a weirdo.
Okay, well then that changes things slightly.
Wait, I'm confused. I'm really bad at doing trick diagrams.
I'm glad you asked that. What's the first split we're going to make? Blue and red. And then we're confused from there. So, red, why Connor was trying to argue that they were equal was they do have equal amounts, but we have chickens, cows, and pigs.
Yeah, I didn't see that they were chickens.
So our chance of getting a red is 1/2.
As long
Chance
as
of
it's
getting a blue is 1/2. Once we come out here to red and we look at those splits, there are 10, 10, and 10. So we have 1/3, 1/3, and 1/3. Meaning the end result of getting a chicken from the red track is 1/6. 1/6 and 1/6. However, the blue box is not so nice. The blue box has 5 chickens, 4 pigs, and 1 cow. Oh, we gotta read. Man, making 10 total. So I guess this would be 1/2, 4/10 or 2/5, we could say, I guess. And 1/10, so we just gotta write 1/10. you guys got to make sure that we keep ourselves in check of acting like we're too good for the math that we're asked to do, because I feel like more and more of this is starting to happen, and then we're actually not correct when we're acting like we're too good for the math, because we're not thinking critically enough. So our blue probability for chicken turns into 1/4. Pig turns into 2/10, or we could say 1/5, I guess, and 1/20. Ooh, common denominator would be a little weird here because 6.
You can go by 20. Let's do 20.
Can 6 turn into 20?
Oh, wait, no.
You can do 30.
Well, hold on. We don't necessarily have to think that hard. 1, 6, 1, 6, 1, 6. We know that this was a half. Right? We know that because red was a half. All we need to double check was, do blue total up to a half? So yeah, actually you're right. For blue we can use 20. So 1/20, 4/20, and 5/20.
That's 10.
That's 10/20. So that's good. But if we want to talk about the chance of, let's say you're not allowed to have a pig, you're not allowed to have a cow, but you've been told that Worthington allows chickens. So you're like, all right, well, what's my overall chance of having a chicken?
25 sixes.
What? Did you say 25 sixes?
60th.
Oh, 60th.
Because I turned them all into 60th.
Ah, so if we have,
Added them together.
what are we multiplying by here? 15? So 15 60ths plus 10 60ths. Okay, so probability of chicken, we're saying is 25 60th. Probability of a pig. I have multiple friends with chickens.
Yeah, because I have friends with chickens too.
You get farm for, like, you get fresh eggs every day. Probability of a cow.
13.
So this would be 3 60ths, 10 60ths, 13 60ths.
Oh yeah, no, it's not just 13.
What?
It's not every
That would be a
time.
weird probability.
Every time you get 13 cows.
And then we check 25 plus 22 plus 13. Does that make 60?
Yeah.
All right, that seems good for us then. So, if this were a different situation where you were trying to predict outcomes, what outcome's the most likely? Chickens. Does this make sense?
Yeah.
Now, you immediately said tree diagram. Could we use a two-way table for this?
I forget what.
Two-way tables are the things that we were talking about yesterday.
Oh.
Maybe that's the segue. So, bivariate data, right? We were talking about bivariate data yesterday, is data that has two different features. So, can we apply that to a situation like this?
Yeah, we did.
Distance 2 by 3. Right? No.
Well, go ahead and jot it down on your paper, see if so you're thinking, yeah, a 2 by 3.
I'm not sure.
Our information back here, I don't know if we wrote it down or not.
You have to make.
Still gonna measure in 60th because it's better, you know?
Because there's red and blue on the two.
Oh, these we know. It's the blue ones that are a bit weird.
Yeah.
Red's the one where they're all equal, right?
Mm-hmm. If you have your tree diagram on your paper, you should have all the data, at least to a usable point. So Connor said, okay, red is the one where they're all equal. So red chicken, red pig, red cow. You said they're all equal. So red had a probability of, well, just red had that probability of a half. So if we put half over here, and then for red, all of these were a third, right?
But that won't work.
Oh, but that doesn't work for blue.
That's what I said at first, but then you just picked up John.
Well, but does that mean that the area model doesn't work? So for an area model, anyone watch Amazing Race?
I watched it a long time ago.
So I happened to be flipping through TV, went on the Amazing Race, and this season it got stopped short by COVID. I don't know if they've gotten to it yet or not. But the challenge was either go decorate cakes that have to be very accurately decorated, or both people get a bullseye in the same round of darts. So immediately my brain went to, okay, if let's say you two are a team for Amazing Race. You don't know that this challenge was going to happen. For both of you to get a bullseye in the same round, it's the probability that you get a bullseye and the probability that you get a bullseye compounding with each other. It's a pretty hard challenge, right? Because like bullseye is really small. All of this to say, an area model, which is what we use often when we're talking about like probability, an area model is like a dartboard, right? The bigger spaces on a dartboard are easier to hit, higher probability. Smaller spaces like the bullseye, smaller probability. That's exactly what the area model is used for. So when we go to write blues things here, and actually we should go ahead and fill in for red chicken. So red, the chance of chicken, we might as well put this in the box because you didn't actually have to write chicken up here. Sorry, my handwriting looks terrible today. Is 1/6, we said. Red pig is 1/6. And red cow is 1/6. But then, okay, if we go in order of chicken, pig, cow, just to keep things straight, what's the chicken probability for blue? Why are you still red? Turn to blue. So this was one, I set my paper down. 1/2 for the chicken. 2/5 for the pig. And 1/10 for the cow. So that's what we have to draw. 1/2 of this for the chicken. 2/5 or 4/10. Right? This is going to be easier if I think in tenths for the last part, so that they have common denominators. Because I have 4/10 and 1/10. I want to imagine splitting this up into 10 pieces. Sorry, 5 really, because sorry, there are 5/10 left. We took 5/10 over here. So this is 5 more pieces. Only one of them goes to cow. Why are you not blue? We don't necessarily have to reduce. Does that make sense for how we could, instead of a tree diagram, if you want to visualize it a bit easier, like tree diagrams are great, but does this actually help me visualize the probabilities? Not really. I mean, I can compare the numbers, but especially if they don't have common denominators, it's real hard to compare like 2/10 to 1/6, aside from saying, well, 2 is bigger than 1, but I mean 10 is bigger than 6.
Well, you could think about the 2/10 is 1/5, and then think 1/5, it has to be greater than 1/6.
Yeah, so absolutely to what you said, like, because you guys are brilliant. But this is a bit easier to see. So I can say, if I want a cow, what would I like my spinner to land on?
Red.
red. I mean, like it's quicker to see certain answers from an area model. So modified area model is what we call this because it's not evenly distributed, right? So the two-way frequency tables that we draw and we just put the numbers into, that's not an area model, right? That's a bivariate two-way frequency table, 2 pieces of data, and we just graph it all and we just make everything the same size. If we're talking probability, we should make it accurate size. Now, would we have to make this accurately spaced out? No, but then it's almost pointless to draw it like an area model. Does that make sense? Moving on, I forget which problem's next. So, I just brought up that I want to get a cow, right? I'm going to make things a bit harder than they were yesterday. What is my probability that what is my probability that my spin was red given that I took home a cow?
1/6 out of 13/60, so it's 10 out of 13.
How'd you figure that out?
1/6 is 10/60.
Well, where'd you pull those numbers? So you said 1/6 out of.
Well, because just like how we were doing earlier, if you have something given, you take all the stuff that's in that category, and then you use it. And so...
So red given cow means that this is now. So given is what tells us what region to look at. Really what tells us what population we're going to use. So red was 1/6 in our table out of 1/6 plus 1/20th, which you said is really 13/60ths. So I could say 10/60ths if I want to, over 13/60ths,
Which is a plus 10.
which if we keep change flip, this really becomes 10/60ths. I know I'm reviewing math that you know how to do, but it's worth writing down to review. Right, division by a fraction, keep change flip, and that's how we get 10 over 13.
No, I mean like
On the top,
yeah, you could have just said, oh, bye bye 16.
Yeah, well, the 7th graders that I teach aren't that comfortable yet with like, oh, I can just swipe both of those out. And any Joe Schmo on the internet, like Jake or somebody else, my mic is there, might need that reminder of division by a fraction turns into keep change flip, but nobody watches my videos, so who really cares? I don't even know if Jake's gonna watch the videos. Hold on, I forget if I had another question that I wanted to ask here. So, yesterday we talked about independence. Are the events red and cow independent with each other? Why? Probabilities change, right? So unless the probabilities are equal, they're not independent. What's the probability of blue given pig? Nope.
12, 20 seconds. 6 11.
Akshay?
Yeah. Well. Right?
So probability of blue given pig. So again, we put probability of blue pig. I'm trying to use.
Which is 12 over 60. Right? Yeah.
This, right? So this is our region that we're using.
Yeah.
So, sure, you can use 12 over 60 if you want to use the non-reduced fraction, I guess. Fine, whatever.
The other one is 10 times 60.
Yeah. So then you add them together.
You add them together and you get 0.5.
Oh, so this is 10 out of 60, so
Right, so
10
it's 2 out of
60th plus 12 60th.
It's very easy to make a mistake with this.
So you guys said I'm just allowed to do that because this does that and this does that as well, and when we have the same thing on top and bottom, we cross it
The
out.
qualitative property of division. I don't know.
You guys go to the fair? I know it's been a couple years since we've probably had a fair, but
The state fair?
or county fair. I don't know.
This one last.
I don't know if county fairs over here are as big of a deal because there's the state fair. So we always spent our time at the state fair either at the booth where you throw the ball and it's got to hit the thing and drop into the basket. You know what I'm talking about?
At
No?
the state fair, that's what you would do?
No, at the county fair.
Oh, it's a county
Our county fair, we would just go every day because it was cheap to get in. Actually, I had a pass because I was a Boy Scout and we had a booth there. So we would just go waste time playing games, right? We would win some stuff. But they have designed this game that they think is a bit more fair because there's math involved. So if you've ever watched any of Mark Rover's Carnival Scam, yeah, so a lot of those games are rigged, right? But if we're playing a game that's mathematical, it's not really rigged except for the fact that the casino or any place like that, they do the math and they only want to let you play the game if what?
It's in their mouth.
If it's in their favor, right? So of course, you might win, but if you only win 1 out of every 20 times, I don't care that you won. Great, good for you. Go tell your friends that you won. They'll come spend their money with me. So, one of the new games at the fair is flip to spin or roll. Yes, they should probably make up a better name. First, the player flips a coin. Sweet. If it's a head, the player gets to spin the big wheel. Spin the big wheel. Has 10 equal sections. 3 are red, 3 are blue, 4 are yellow. I might as well highlight this with that since it's big wheel data. If the coin comes up tails, you roll a cube, so a die, but it's easier to say a cube. But instead of being a number cube, it's got colors also. 2 are yellow, 1 is blue, 3 are red.
Wait,
If the-
what area?
It's up here. 3 red, 2 yellow, 1 blue. If you end up with a blue, you win. Whatever diagram you want to use, let's diagram this out and figure out what's our chance of getting blue. The what?
This game doesn't seem all that good, I'm gonna be honest.
Well, depends who you are. Are you the owner of the fair? Or are you the person playing the game?
Well, for the person playing. That's less than a fourth chance if I do my math right. I think this game is not fair. What are you talking about? Although I guess that's worth a shot. It's not that bad.
So what's our probability of winning? Or do we not have it yet? 14 60ths?
Or you could do 7/30. That's what I got.
Yep. If I modified area model this, because guys, I don't love tree diagrams, gonna be honest. Like, I like them, but when we get into more complex questions, it's just not that powerful. the modified area model is a lot more powerful.
Also, it's very limiting because you can't really go past 2. I can't think.
That is the problem. So you literally took away my segue, which is fine. I love when you guys do that. Is the modified area model is fantastic when there's only 2 different things occurring. If there's a third layer of something happening, it's kind of stuck in needing to go back to a tree diagram. So if I take my blue from here and my blue from here, we would add them up with a common denominator and get 14/60ths. However, what if the question we want to answer is you see Tyler walking down the fair, whatever, and he's holding a big stuffed animal. He won the game. What is the probability he started off by flipping heads? And it is not 1/2. Because you know that he won. I'm going to give you guys a second.
Wait, huh? That literally can't be right. I got 9 out of 5.
I don't think that's right.
Maybe it's 5 out. Oh, because it's 9 out of 14. Okay, that makes more sense.
So Tyler won. So we know, I'm going to cut this. So I can highlight some of this. What do we have to get to win? Blue, right? So that's going to determine our sample space that we're working with. So that's our denominator then, right? So that's 9/60ths plus 5/60ths. So this is 14/60ths. Oh yeah, we already calculated that because that's the chance of winning.
And then it's just the 9/60ths because that's heads.
So then it's just 9/60ths over that.
Heads victory.
So if it's 9/60ths divided by 14/60ths, we can get rid of both of the 60s. And it's 9 over 14. Does this make sense? Okay, thank you, because I felt like you were being very quiet. When we say we know Tyler won, that creates that. Because we know that to win in this situation, you gotta have blue. So we're saying it's a given he had a blue at the end. What we're asking is what are the chances that he had a heads to start. So
okay, now it makes sense.
the tricky part is heads is not 1/2. And that's like the gut reaction of what's the chance of heads. In this situation, it's only the heads from here. So this is our sample space, or like our dartboard, whatever you want to say. We take our numerator as the blue heads, and then our denominator is everything blue. Does that make sense? Okay. Raul, conducting a survey, because that's what we all do in our free time, right? Do you guys do chores at home?
I'm just forced to do it.
I sometimes do chores. I mow the lawn if I want one.
Yeah, I mean, I think doing chores prepares you for real life. You always have to do chores. Like, there are dishes to wash in my sink right now, so when I get home, guess what? Probably gonna wash dishes. Yeah, but they're like pans. I made a honey glazed pork tenderloin last night, so I have a pan full of honey that I now have to clean. Huh? Sorry. The pork was dry, so if it makes you feel any better. It wasn't that great. I left it in for too long. I put in the food thermometer and it was like, whoa, you're too hot.
You said too hot.
The alarm went off because you can set your temperature for to make sure it's done. And I was like, oh no, I overcooked this. All right, back on topic though. Raul surveys 200 senior class students, finds 78 students have access to a car on weekends. 54 have regular chores assigned at home. 80 have neither a car or chores. And we want to fill in this two-way frequency table because we think that's the best way to model this data. So no cars, no chores is 80, you said.
Yeah, I think I agree that two-way frequency table is probably the best.
Why does it say you have access to a phone?
Because that's the question they asked. Do you have chores and do you have access to a car on the weekend? So imagine if Raul is trying to argue with his parents that because he has chores, he should get to use the car on the weekends, like if he doesn't have his own car. So he did this survey to try to get the information he thinks he I'm trying to make sure I don't trip on words, but I don't know if there's any avoiding that. He wants to prove what he wants to prove. He's hoping to find out that there is a positive relationship between having chores and getting access to the car. Where would that 200 go?
At the corner.
Like out.
Out here. Okay. So it's going to be the total of that and the total of that.
Oh, he's going to be annoyed by that.
78 for cars and
78 for what?
car and has chores.
78 goes here.
No, 78 students have access to a car on weekends. It doesn't say anything about it.
Oh, okay. So then it goes outside.
So here.
No,
No,
other outside.
yeah.
Here. Because that was car. Okay.
And then 200.
Also, you have 54 students.
Where's that go?
So 100.
Where you were going to put
122
78.
goes below 180.
Not the first
below
time, the
80.
second time.
This?
Yeah.
Okay. We got the 80 in there.
122 goes below 80.
122 goes here. Oh, because this plus that has to equal 200. Okay.
And then 1646 goes next to 80 to the right.
What? Sorry.
Below 54.
I'm not being goofy. What number?
146.
146. Sorry, you said a few different digits, and I couldn't quite tell the order. You see the dominoes starting to fall?
Now you just do what you
Now,
did figure
above 80 is 42. And then,
I think I can do this math.
Oh, really? And then it's 78 minus 12.
and then just to make sure.
You can have all together.
Yeah, what?
So, what do you guys think? Is there an association? Is there a relationship
Yeah, people who don't do chores have cars more.
Yeah.
He's proven himself wrong, if that's what it's doing.
What do you think that means? Like, if you collected this data and that's what you found,
It means the lazy parents that don't make their kids do chores are also the parents that let their kids get a car.
It's spoiled.
Interessante.
And then there are also some kids who do chores.
You said do.
Ha 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 ha.
So, the chance of having access to a car.
It's one. No, it's
So, 78 out of
200.
200. So, percent-wise, we're talking like 30,
No, 39.
39, right? So, the chance of having a car is 39%. So, probability of a car. What's the probability of having access to a car given that you do chores?
Well,
78. Wait. What was the question?
What's the probability of having access to a car given that you have regular chores?
12 out of. No, 54.
Ooh, 12 out of 54. What percent's that turn into? You got your little fancy wrist calculator.
And then what? Wait, well, part of it 54 is 0.2 continuous. So
No,
that's
it's fine. 50%.
So, are they independent? No, because the probability changes, right? Probability of having a car compared to probability of having a car given chores. If they're not equal, there is some sort of association, right? We said we don't necessarily say dependent. That's interesting. So the probability of just having a car is higher than having a car with chores. Connor's argument is, well, these parents up there are kind of lazy. Your word, not mine. But I agree with you.
And they let their kids do whatever they want.
Yeah, just like, oh, you didn't take out the trash. Okay, I'll do it. Here's the car keys. Like, yeah, it's interesting.
Except for those 12 people who have a car and chores, which are probably the kids whose parents are like, I'll get you a car if you do chores and pay for it yourself. And then they're like, okay, I'll do the chores and pay for my car.
Right.
you get paid for chores.
I mean, that's
Like,
what an
it is
allowance
labor.
is.
I don't.
Do you get an allowance?
I don't get an allowance.
I get paid a lot of money if I mow the lawn.
What? You get paid a lot of money?
Yeah, like $20.
That's as much money as I make.
That can't be true. For
I
mowing the
I
lawn?
mow my neighbor's grass for $30.
30?
Yeah, because it's a big yard.
My
And
yard
it's
isn't-
and it's my lawnmower and my gasoline and like it's all my
Oh, you use
stuff.
Gas.
What, you have an electric lawnmower? Ah, you're electric.
It's better for the environment.
Oh, I know. I just can't afford to buy one of those right now. This is why this is meant to be a 2-day lesson, because we've got a couple more problems to play with. It's time for lunch. Do whatever you can from the homework. We can talk about if you have to do all of them tomorrow. Do at least the problems that look directly related to what we're doing right now. So if you want to skip a problem about like similar triangles, whatever. If you want to skip this multiple choice, I'm sure you can solve it on your own.
What if we just do like the first?
I would try to factor. I would do for sure 84, 87.
That's been really.
Yeah, probably like
87.
87, 91, and 92. Yeah, 84, 87. You should be able to do 89. I mean, we all just mastered that on the test that we just took.
Aren't those basically just like roots though?
Yeah, because they all have a power of 1, yes. But it's without a calculator. That's kind of the tricky, not tricky part, but... Yeah, and for sure do 91, 92.
In science,